But as we talked about the poll, as Rachel had already mentioned, this is approved for 1 LUHSW through AIA, and quickly jumping right on into it. So in today's session, we're going to take a look at integrated sheathing systems and their installation methods, and how some of those installation methods may deviate from the installation of standard wood structural panel sheathing, and some additional steps that might need to be taken into consideration when installing these integrated systems to prevent the risk of building enclosure failure. A couple learning objectives that I want to touch on here is that we will review the installation instructions for these systems in regard to their structural specifications, in regard to how to install them so that you have a complete water resistive barrier per their specifications. We'll also take a look at a comprehensive option, how the integrated sheathing systems can be a comprehensive option to a standard wood structural panel sheathing system. And then finally here, we'll look to see if, we'll look at how these integrated sheathing systems can provide an alternative, or the potential to be an alternative to conventional wood structural sheathing as it pertains to air barriers, water resistant barriers, along with the structural component and how it can be a holistic approach. Before we go any further, I do want to throw this out there. It's not very often that the PHRC throws out disclaimers, but I do want to make everybody aware that at no point throughout this presentation is there an intent to promote any specific material. There's a lot of stuff out there that you can look to that does that. We're not here to do that. What I'm here to do today is look at the products and the methods of those products to be installed, and leave it to you as the listener taking this information and giving you the information so that you can make the most informed choice possible on your end based on the designed assembly. So with all that being said, we'll jump right on into it. So first things first, what is sheathing? What are we talking about here? Initially, when thinking about what sheathing is, wood structural panel sheathing anyway, you come to two different conclusions. And the first one here is plywood. You hear a lot of people talk about using plywood as their wood structural panel with the sheathing on whatever structure they intend on building. And what this is about here is kind of showing the structural differences between plywood and OSB, what we'll look at next. But the composition of plywood is thin wood veneers, and that's the starting block, right? There's a difference between plywood and OSB. The first and foremost is that that plywood is thin wood veneers. So they take the log and they actually peel layers off of it, which gives you a nice thin layer, and then they glue those together so that each layer of that veneer is perpendicular to the adjacent layers. And this is what that does look like. This comes from APA. As you can see here, the face layer on top has the veneers with the structural grain running in the long portion of the plywood, and then it alternates every layer below that adjacent to the top layer. And that is the construction method for this is a 5-layer sheet of plywood, and you can get different layers of plywood depending on thicknesses. Looking at the second type of wood structural panel, or typical wood structural panel that you're going to see out there, is oriented strand board, or from this point moving forward, I'll refer to it as OSB. And the composition of these structural members is that they are wood strands. So as you can see in this picture here, the plywood had veneered wood where it was peeled, and each layer for the most part was one continuous thin veneered layer. In an OSB panel, you have wood strands that are bonded then together under high heat and high pressure that presses it all together with a bonding agent. And this is what you have. You can see here where we have the smaller strands, but again, they are put together in some sort of orientation, right? So here we have our outermost layers with the strands facing in, or the longer portion of the strands running in the longer portion of the panel, and then our internal pieces are perpendicular to that, where they're running the oriented strands are running in the shorter portion of the panel. That ultimately gives it its strength rating, and whenever you look at OSB, they have a stamp on it that says the span ratings, and these orientations are what gives it those strengths in those specific orientations. So 3 main purposes of sheathings. I'm sure there are more purposes to sheathings, but I'm going to briefly touch on 3 of them here today. Number 1 is strength. We're putting these panels, wood structural panels, on the outside of our homes because we want to increase the strength of those walls. Primarily, we want to combat the forces of against lateral forces. We want to combat against lateral forces. It also fights against shear loading and reinforces the pore geometry of the stud. So if you can imagine taking a straw, right, and pushing down on that straw, it's strong until it begins to bend. And once that begins to bend, it collapses rather easy. When we talk about reinforcing the pore geometry of the stud, that's kind of what we're talking about here. When you have a stud standing on end, it is extremely strong until we start to get a bow or something coming out of plane within that stud. And once that happens, we lose a lot of our structural integrity. And what these wood structural panels are doing is through the connectors or the fasteners, you are reinforcing the pore geometry of that stud. So looking here at lateral loads, you're primarily going to get these forces in 2 different manners. One would be the top portion here, which is wind. Here in Pennsylvania, our design methods have wind governing our lateral loads. So we would be looking at wind maps, things of that nature, to find out what sort of lateral loading forces are going to be applied to our homes. Our structures. Moving out west, that can transition from wind being the primary lateral force load to earthquake or the movement of the earth, introducing lateral loads into the structure. So by looking at how that lateral load is applied to the structure, we can then assume or take into consideration how the design has to be to combat these forces. So looking at this image here, why wall bracing, right? So we have a rectangle structure displayed here, and we have lateral forces being applied through wind to the long portion of the structure. I believe my cursor can show up on your screens as well. So we see this lateral loading being driven against the long portion of this. That means these braced wall panels perpendicular to those wall lines have to have lateral load reinforcement. If these walls were simply designed with simple studs and nothing applied over top of that to help combat against lateral forces, then it would be rather easy to push this over with a racking motion where these studs come out of plane because there's nothing holding them laterally in place. I'm sure that there's been many pictures floating around, and I should have snagged one to put into this presentation of homes where they were being constructed, the wood structural panel, whatever was being used as the lateral reinforcing was not installed on the walls. A windstorm came through, and you can see all of the vertical studs were no longer vertical. Things collapsed, and that is obviously not what we intend to have happen for our structures. We want them to withstand any sort of loads applied to them, and for lateral forces, wood structural panels are one of those items that we can install to combat that. This here, wood structural panel sheathing, or wood structural panel, or WSP, is a method for wall bracing prescribed within the code. So there are other methods out there, but keeping with the theme of today's presentation with integrated sheathing systems and wood structural panels, we're going to talk about, or at least use that as our guiding force for wall bracing today. Here's the same image that we had 2 slides ago, where we have our lateral loading being applied to this long wall, and then we have our braced wall panels that are now perpendicular to the braced wall line. And the addition of these braced, or the wood structural panels, now reinforce those stud connections and can now resist the lateral forces, in this case wind, being applied to the long portion of the wall. So this can be done through many different means and methods, but the starting method for attaching these wood structural panels comes out of the code. And here we have a nailing pattern of 12 inches on center in the field and 6 inches on center on the edge. The sometimes more important to understand is not necessarily the pattern that needs to be used, but it's the size nail that needs to be used. This is calling out for a 6D common nail. If you were at a conference, and I might jump back to our conference a couple times through today's presentation. But Walt Schneider and Matt Hunter did a really good job, explaining the differences and some of the misconceptions on the 6D common nail in comparison to a nail gun nail. And you're not gonna be shooting 6D common nails out of a pneumatic gun. So you need to make sure, ensure that the nail that's chosen to be used within that nail gun is compatible or is equivalent to the 6D common nails for these fastening patterns. So number 2 here is encloses the building, right? So we have number 1, the purpose of our wood structural panels or sheathing is for strength. Number 2 is that it encloses the building. And 2 items here. Number 1 is the standard wood structural sheathing. Is it an air barrier or can it be an air barrier? And the second point here is a water resistant barrier. Is it a water resistant barrier and can it be a water resistant barrier? So to touch on those 2 points, I do believe that wood structural sheathing can be an air barrier. I've seen several builders use wood structural panels or their sheathing as their air barrier. However, standard wood structural sheathing cannot be used as a water resistant barrier unless something additional is, or cannot be used as a water resistant barrier, and you have to look to additional control layers to be installed in that assembly to be your WRB. Jumping into integrated sheathing systems, it can be both, right? That's the whole point of the integrated sheathing system, is that it can be an air barrier and a water resistant barrier, and the installation guidelines kind of point you in the direction of achieving both. So looking at the sheathing method as being used, as in this case here would be your air barrier. Some things are critical points that have to be looked into is the sheathing going to be continuous, right? And to make this continuous, you have to look at some additional trouble spots because you have interruptions. You can't get, if you have a 40-foot wall, you can't get an 8-foot or 9-foot by 40-foot piece of OSB or plywood or whatever it may be. So to make it continuous, there has to be some sort of added material to fill up those joints or to stop that air leakage whenever you have interruptions within that structural sheathing. All sheathing joints to combat that must be either taped or sealed by other means. Typically, when your standard wood structural panel, OSB or plywood, is being installed, tape has to be the surface has to be prepped, and that takes additional steps. So a lot of times that's taken in. The other methods are being looked into, and look at one of those here in the next couple slides. So as you can see here, this is an exterior shot of a home that has wood structural panels installed on the outside of it. You can see exposed seams here at the corner over top of the window, and that's okay. That's how these systems are to be installed. However, you do have to take one additional step, and that's ensuring that we have an airtight seal at all of the edges, all 4 edges, top, bottom, left, and right, to stop the movement of air, because as we all know, air doesn't move vertically like water does most of the time, unless you take wicking into consideration. But air will always find the path of least resistance when it's under pressure. So we need to make sure that we seal the tops of these wood structural panel sheathing. The bottoms, I don't know if you can all see that, but down here there's foam again in each of these bays, sealing up for air intrusion. And then whenever we have the length of the OSB in this case being installed, the butt end over top of a stud, both sides of that stud also need to be sealed. Otherwise, air will find its way in between the back side of that stud and the inward side of that OSB, again in this case, and through the gap between. Because keep in mind, we'll talk about this later on, but there needs to be a gap in between these panels during the installation for any sort of expansion. If that OSB or that wood structural panel is not being used as the air barrier, then there's the ability to use house wraps also as your air barrier. I will say that most of the manufacturers of house wrap do allow their house wrap to be used as both the water resistant barrier along with the air barrier. However, you're probably going to see two different installation methods, one for each, right? You'll have an installation guide for the house wrap to be installed as a WRB, but then you'll have a standalone separate piece that's in addition to the WRB installation for that to be used as an air barrier. Again, that has to do with how those joints and seams need to be taped, how that needs to be capped at the top, how that needs to be ended at the bottom. So there's a lot of things to take into consideration. I've had many conversations with builders, and I've asked them, what's your water or what's your air barrier? And they're like, my house wrap is my air barrier. So then I take it a step further and ask them how the installation goes with the sealing with caulking at the top, sealing with caulking at the bottom against the foundation, and they aren't sure on how to answer that. So just take a step back. If you are a builder or a designer and you're calling out for that house wrap to be used as your air barrier, take a moment and look at the installation guide that you're referring to, or the installation guide that you're providing with your installers, or whatever the case may be, to ensure that you are indeed using that WR or that house wrap as an air barrier as intended through the installation instructions. So here's a great picture showing the installation of a house wrap. I would venture to say that this house wrap is being used only as a WRB and not being used as an air barrier. I'm not seeing any sort of tape on the horizontal seams. Most manufacturers, if being used as a WRB only, you have to have a lap, but tape is not always required on the horizontal seam. Vertical seams need to be taped. Again, though, this is a good installation for a water-resistant barrier. This installation here could be used as an air barrier because we have all of our seams being taped, both vertical and horizontal seams. I cannot tell for sure if we have sealing at the top or at the bottom, but at first glance, this could be an installation for that to be used as an air barrier. And then finally here, and I don't have any pictures, I'm not going to elaborate because we can all understand that this wood structural panel can be used as a nailing surface, right? For the installation of rain screens, for the installation of siding, for the installation of trim. When installing these products, you're not always at the mercy of being able to hit a stud. So some of the installation for these types of materials allow for it to be installed directly to the substrate behind, which would be, in this case, your wood structural panels. What is an integrated sheathing system? So I pulled together some bits and pieces from several different articles, and this is what I came up with for a definition for integrated sheathing system, which is a wood structural panel with a built-in protective layer that can, under most circumstances, remove the need for an additional layer of house wrap or building paper. There may be installations of specific assemblies that can require additional control layers. An example of what that is, of where you may need additional control layers, is the installation of a plaster-based system, whether it be stucco or adhered masonry veneer, where you have to have, in Pennsylvania under the 21 code, which was adopted at the same time as the 2018, is that you have to have 2 layers of 10-minute grade D paper or 1 layer of 60-minute grade D paper. If you look at the specifications for the majority of the integrated sheathing systems out there, they don't meet the 60-minute grade D paper, so there will be a need to install a secondary water-resistive barrier or house wrap to meet that need. So working through the different manufacturers that I'm going to discuss here today or work through, we have the Huber zip system, we have the LP weather logic, and we have the GP force field. I'm not saying that we're limited to only these products. I'm just saying that in today's presentation, we're going to look and use these 3 different manufacturers and these 3 different products as examples to show different installation techniques, different installation methods, and different guidelines for the big one that I'm going to talk about is overdriven fasteners and different things that you have to do when that happens within those systems. So the installation of the proprietary integrated sheathing system, all OSB installation guides require an 1/8-inch gap per industry standards between all panels in all directions. Jumping back to our conference that we just had, Noah Humberston from APA did a really great job in working through this installation method for OSB to be installed as sheathing, and how critical it is to have that 1/8 of an inch gap that is in all of the installation standards out there. OSB, plywood, they are made of wood. Wood will, it's a natural material. It will expand and contract based on its environment. And once you get moisture into these wood structural panels, they will expand. This doesn't have to or always be bulk moisture. This could be a drastic change in relative humidity that can add enough moisture to these products where they can expand. And if these are installed, tight together, you will see waviness in the exterior walls. So if you're looking for more information regarding that specific detail, like I said, Noah Humberston did a really good job at our conference explaining that through APA. So I would encourage you, to reach out to him with any questions or concerns going further on that topic. But again, we're looking at 2 different installation methods here. All of them have it. But in the middle, on the lower portion, we have a weather logic, which specifically calls out for an 1/8 of an inch gap. As you can see here in bullet point at the bottom here, the second one here says some products have a unique factory edge that helps with the spacing. And then we look at the image on the right-hand side that is showing that Huber does have a factory edge on it that helps create that 1/8 of an inch gap in between panels. This factory edge is not on all of them. It's on the 8-foot pieces or 8-foot edges. The 4-foot edges don't have it, so you have to manually adjust that spacing. But if you look, I have all of the pictures that are pulled from documentation online specifically to the manufacturer. I have the website shown on all of these images. I saw that Rachel had posted earlier on the link to the handouts to today's presentation. So if you want to go back and revisit, or thank you for sharing that again, Rachel. If you want to go back and revisit any of these images or look at these installation guides in greater depth, feel free to jump on to onto the website and pull the handouts, and you can take these links and it'll take you directly to those documents. So fastening schedule, as I said earlier on, when we're talking about the standard wood structural panels, that the fastening schedule that comes right out of the code is 12 inches in the field and 6 inches along the edges. Note number 1 here, this is kind of their covering, stating that panels are to be fastened according to project specifications and local building code requirements, right? And then you dive a little bit deeper, and it does give you those general guidelines for fastening schedules, which again, come back and call out that 6D common nail, 6 inches on center along the edge, and 12 inches on center in the intermediate supports. However, it doesn't end there that doesn't cover everything. There are specific details out there that can go above and beyond. Here I have just one example of a detail, and this detail comes from APA. You may have plan specific details that an engineer provided with different fastening schedules. So please, don't take it for granted. Make sure that you're looking and finding that fastening schedule for specific details. In this case here, APA has their portal frame detail. Some of you are probably familiar with that. Looking at braced wall panels in small areas, this portal frame is typically used around garage doors or smaller walls with large openings. And the pattern there is 3 inches on center, which is much tighter, but it goes beyond that as well. And now you're looking at an 8D common nail as opposed to a 6D. So not all nails are created equal, and not all nailing patterns are created equal either. So I really wanted to bring this portion in. You hear folks talk about overdriven fasteners and immediately jump to the point where, oh my goodness, it's an overdriven fastener that compromises the water resistive barrier for the entire system, therefore it's no good. Or you have an overdriven fastener, and now the structural characteristics for those wood structural panels are null and void. Now we have structural concerns, and that's kind of going from 0 to 100 way faster than what we probably should. These and I have the structural concern and the water resistant barrier concern for overdriven fasteners for all three types of products that we're talking about here today. And they all kind of walk down the same path. And a couple of them even point to an additional document provided by APA. But the first one here is through Huber's zip system. And again, this is pulled from their FAQs off of their website. So this is specific to the manufacturer. So what's the structural concern with overdriven fasteners with the Huber zip system? And it goes on to say that the APA and PFS TICO recommend either reducing the allowable shear capacities or installing extra fasteners if fastener is more than 1/8 of an inch overdriven, or more than 20% of the fasteners are between a 1/16 of an inch or an 1/8 of an inch overdriven. So we can look at this panel, right? And if we have 3 fasteners that before they got their nail gun dialed in, overdrove those fasteners 1/8 of an inch. So now if we just come back through and install a fastener next to them that is not overdriven, we're good to go. But if less than 20% of those fasteners are between a 1/16 and an 1/8 of an inch overdriven, we're still okay in the structural concern path. Moving on to the WRB concern, again, I've heard, I don't necessarily know if I should go as far as to say that it's like misinformation, but it gets thrown out there a lot that, again, it's overdriven, therefore it compromises the entire panel. And as we can see, it's not always the case. So we could take a step back that says overdriven fasteners do not necessarily void the sheathing warranty. However, when a fastener misses the framing as a result, called a shiner, right? If we install a nail and we miss the stud behind, that's in this case here called a shiner. If the fastener penetrates roughly halfway or more through the panel, steps then must be taken to seal these penetrations, right? So you have to pull those shiners out, and then you can cover that with this product's tape, zip system tape, or liquid flash. Then fasteners that penetrate roughly halfway or more through the panel itself should be covered with some sort of tape or liquid flash. Now, there's a little bit of combativeness between the two here, right? It says under the WRB concern that if fasteners penetrate roughly halfway through, that's greater than what we're being shown up top here. So yes, if it's halfway through, if it's overdriven halfway through the panel, we can then install tape or liquid flash over top of it, but then we also have to come back and readdress the structural concern. However, there's still a fix for both. Moving into weather logics for overdriven fasteners, the structural concern refers to APA's technical topic, which is TT number 012, and we'll jump to that after we cover the next slide as well. Moving down into WRB concern, obviously we want to avoid overdriving fasteners. They lead to water intrusion. If you see the white of the OSB beneath the surface of the WRB membrane, then the nail is to be considered overdriven and needs to be covered with the proprietary tape. In this case here is LP WeatherLogic tape, or with an AMA approved liquid applied flashing. Right. So in this aspect for this manufacturer, it's if you can see the white surface behind the WRB membrane, that nail is to be considered overdriven in regard to the WRB, and then needs to be addressed with some sort of tape or liquid applied flashing. And again, we'll come back and address the structural concern here in a moment. The third one here is force fields. Again, the structural concern points us to APA's TT-012, which again is the name of that is effective overdriven fasteners on shear capacity. But jumping to the WRB concern for this product, it states that to help maintain a continuous air and water resistant barrier, fasteners that have been overdriven more than a 1/16 of an inch past the panel surface should be treated with an approved, again, proprietary tape. In this case is force field, or some sort of, in this case, densified liquid flashing. This did give a nice image in their technical bulletin for overdriven fasteners through GP's force field. So again, 3 different products address overdriven fasteners, especially on the WRB side, a little bit different. However, none of them say that once you have an overdriven fastener, it's null and void. There are precautions, or there are steps that have to be taken to ensure the integrity of the WRB, but it's not a throwaway concern here. Taking a quick look at APA's, again, technical topic TT-012, the effective overdriven fasteners on shear capacity in regard to wood structural panels. And it says right up top that the following is a suggested guideline for determining if overdriven fasteners will affect shear capacity of diaphragm or shear wall construction. When looking at these wood structural panels, and if you are installing them to be used as shear wall construction and you have overdriven fasteners, you typically have to jump into this. If their installation guides point you to it, otherwise you look at their information if they provide it like you were. But number 1 here says that if any case described below is met, no reduction in shear capacity needs to be taken. I had to read that a couple times because it's kind of, when working through the code doesn't necessarily put it in these terms. It usually says it in a different fashion. So this is a little bit outside. I had to read it a couple times to ensure that I was on board with what was being said here. But again, if any case described below is met, no reduction in shear capacity needs to be taken. The first one here, A, all nails driven into the panel are no greater than a 1/16 of an inch during construction under dry conditions. So as long as that panel is considered under dry conditions, which means that the moisture content of those panels is less than 16%, as long as all overdriven fasteners into the panel do not exceed a 1/16 of an inch, you're okay. You're considered to be good to go with the structural concern for that panel. B, if no more than 20% of the fasteners around the perimeter of the panel are overdriven by no greater than 1/8 of an inch, right? So we're looking at the exterior, or the edge of the panel going around, and as long as no more than 20% are greater than 1/8 of an inch, then you are okay to go there. Assuming that they are looking at the edge of a panel and compression can happen a little bit easier, therefore 1/8 of an inch is their cutoff for APA's technical topic here. C, if all fasteners around the perimeter of the panel appear to be overdriven by the same amount, and it appears that the panel may have, or panels have been wetted during construction, it can be assumed that the fastener embedment is due to the panel thickness swelling. Okay, so if we're looking and taking judgment on this panel, and if you're looking at the edges, and if all of the fasteners around the edge are overdriven the exact same amount, and it looks like that panel had gotten wet, you can assume then that those overdriven fasteners are being shown in that way due to the swelling of the panel and not necessarily overdriven through installation. And then we have D, which is if actual panels used in the construction are thicker than the required minimum nominal panel thickness upon which the design shear capacity is based, all of the overdriving is less than or equal to the difference between the two panels in thickness. So what that means is, in round terms here, if the requirement or the required thickness of the panel to be installed is a 1/2 inch, and 3/4 inch sheathing was installed, and those fasteners were overdriven a 1/4 inch, that's stating that the overdriven fastener does not exceed the minimum panel thickness required, therefore it should be deemed compliant for structural concerns, because a 3/4 inch panel wasn't needed, only a 1/2 inch panel was needed, and the shear capacity is based on a 1/2 inch. And then number 2, again, number 1 was if any of the cases below are met, reduction in shear capacity should be taken. Number 2 here is if more than 20% of the fasteners around the perimeter of the panel are overdriven by a 1/16 of an inch, or if any are overdriven by more than an 1/8 of an inch, an additional fastener must be driven in to maintain the required shear capacity. And then we have a number here: for every 2 fasteners overdriven, 1 additional fastener must be used in this application. So if more than 20% of the fasteners around the panel are overdriven by a 1/16 of an inch, or if any of them are overdriven by more than an 1/8 of an inch, you must install 1 additional fastener for every 2 that are overdriven. Okay. When it comes to percentages, sometimes that's difficult, right? You're looking around and counting the number of fasteners and things of that nature. But again, more than 20% of the perimeter is overdriven by a 1/16, or if any is overdriven by an 1/8 of an inch, you have to install 1 additional correctly driven fastener for every overdriven fastener. Now, again, these two come out of APA's technical topic, TT012, effective overdriven fasteners on shear capacity, and both weather logic and force field direct the structural concerns of overdriven fasteners to this document. And again, if you're looking to obtain this, it's a free download. You can search the TT-012 from APA through Google, or you can jump on APA's website and get a free download of that for your reference. All right, moving along. Boy, we got a long ways to go in 15 minutes. Integrated sheathing tape installation. This is where it really comes down to it, right? So tape for all seams are required on all seams, right? Or for all systems are required on all seams. Surface preparation is key. And this is, I should have put this in red because this is probably one of the most important things in regards to the installation of tapes, is that the panel must be dry, the panel must be free from frost, and the panel must be free from dirt and debris and sawdust. If the panel, if any of these are happening, and if that tape doesn't stick, there are major, there could be major concerns for water intrusion. So the system requires this tape to be installed correctly for it to work effective and efficiently, and it must be installed in a shingle fashion. Most of these tapes are pressure sensitive, therefore you have to use a J roller in this case to install it. or to activate that adhesive so that the tape is going to be installed. And then you come back with, here on the left-hand side, we have just a generic J roller that you can find on Amazon, right? And on the right-hand side, this is Huber's proprietary specific roller that can be used. Either which way, a lot of these tapes are pressure sensitive, and the installation instructions will say that you must roll or pressure activate the tape, and it can be done through using these J rollers. Proper overlap at the intersection and splices. Please refer to the manufacturer's installation instructions, as they do not all say the same thing. However, looking at typical dimensions, when looking at the overlaps at T intersections, it's roughly 1 inch, and then 3 inches on overlaps, right? So what that looks like here on the left-hand side, we have an overlap. We have one manufacturer calls out for a 3-inch overlap zip, and then the Weather Logic calls for a 2-inch overlap. Again, look at the specific installation instructions. That's your overlap. Makes sense. These are your T intersections that they're talking about over here on the left-hand side, the bottom picture. That's your T intersection. And they're specifically calling out a dimension there of a 1-inch overlap, because they want to ensure that we have proper adhesion above that intersection. Therefore, over time, water doesn't get behind that and then get behind the vertical tape and get into your joints. So again, there are guidelines on the actual overlap of the tapes for these installations. I wanted to quickly cover window installations. Again, this should be installed per the manufacturer's installation instructions. This one here is for Zip, where they have their stretch flash, which needs to be installed at the pan. And then it calls for adhesive to be installed on the flanges of the window, and then that's to be installed. And again, always think shingle fashion. So we're installing first and foremost the seam tape at the bottom below the window. Then we're installing our pan flash. Then we're installing our window with our jam tape. And then we're installing our head flashing, or our head tape here. Keep in mind, this is a T intersection, so we want to make sure we overlap 1 inch for that. And then we want to, again, install our vertical seam tape above that, still continuing down with our shingle fashion. I am not going to read this, but if you take a look over here on the right-hand side, their initial installation are for standard windows without flanges. Therefore, they're requiring force field flex flashing at the pan down here. Then they're installing, it's called AT flashing, on both jams and the head of the roof opening. And then if you're going to go ahead and install beyond that a window with a flange, you then install the window and you install the jam flashing with using their AT flashing tape, and then you're installing your head flashing, and then of course concluding shingle fashion with your vertical seam tape. The final installation for Windows is through Weather Logic, and this simply calls out for their seam and flashing tape to be installed in all areas. I'm not going to continue to move on repeating myself, but they want the installation of the vertical seam tape first, then looking at their pan flashing, installing of the window, jams. This specifically calls out for your 1 inch here for your T intersection, and a 2-inch overlap at the bottom. That's 2-inch wide tape, and then a 2-inch extension beyond the jam tape over here on the far right. Again, depending upon the proprietary manufacturer that you're using, please be sure to follow their installation instructions, as they are all slightly different. All right, so looking at the vapor permeance, along with some air permeance of these products, looking at the throttle. So in that assembly, right, you want to make sure that you can identify what your throttle is. And your throttle in regards to the vapor permeance is the material within that building enclosure assembly with the lower vapor, the lowest vapor permeance. This material will limit the overall amount of water vapor that can travel through the enclosure via diffusion, and vapor retarders are throttles by design. So once you say vapor retarder, it's extremely important to know the classifications of vapor retarders, where this is probably not new to the majority of you. Those of you who tuned in, at least to my um, uh, moisture control layer webinars and things of that nature, we've covered this extensively. But just a quick recap, a class 1 vapor retarder is something that is less than 0.1 perm. That's effectively a vapor barrier. Class 2 vapor retarder is anything with a perm rating of 0.1 to 1, and then a class 3 vapor retarder is anything that's 1 to 10 perm. Something that's above 10 perm is considered vapor open. So OSB perm rating, do some research on this. You'll find a large range in documentation stating what the permeability or permeance is of OSB. This here comes from Building Science Corporation, and it states that down here, OSB is approximately 2 perm. I have seen some documentation out there as low as 7/16 OSB being a 0.92 perm. So that jumps you down to a class 2 vapor retarder. What I can say is that the majority of your OSBs fall between a class 2 and a class 3 vapor retarder, and a lot of that can vary depending on the relative humidity. OSB can actually change its permeance based on the relative humidity, so that can change. But more oftentimes than not, you're within that class 2 to class 3 rating, looking at anywhere from a 0.92 to a 3, sometimes 4 perm. Looking way back to the beginning, when we're looking at a standard wood structural sheathing and using some sort of a house wrap as your water resistive barrier, and I just wanted to throw this in. These are 3 fairly used house wraps for used as water resistant barrier. We have Typar building paper, which comes in at 11.7 perm. We have Tyvek house wrap, which comes in at 54 perm, and then we have Benjamin Obdike's flat wrap HP, which comes in at 16 perm. So looking at the perm rating for zip here, we have 12 to 16 perm, and this comes with the testing method of ASTM E96 procedure B, which is the water method. But make sure that you read everything before you jump to conclusions, right? Because if you look at our title here, this is the vapor transmission of only the water resistive barrier layer. That is not the panel as itself. So if you do a little bit more looking into this, you can find through Huber's website that the vapor permeability of the entire panel is based on the permeability of the OSB, which can come in between 1 and 3 perm. As I said, it varies depending on the relative humidity. Again, the water resistant barrier layer of the panel is 12 to 16, but your throttle in this particular product is the OSB itself. Horsfield comes in with again a water vapor transmission using ASTM E96 water method. We're looking at the same apples to apples here. Comes in at greater than 2.75 perm. Looking at the laminated panel. So this falls right in line. It's roughly that same perm rating using OSB as again your throttle. And the last one here that we're going to look at is Weather Logic. This comes in at 5.35 perm, which again comes in ASTM E96, the water method again. So this is looking at the panel. This has one of the greater perm ratings. Again, OSB can vary, but we're looking at that OSB still being the throttle. Okay, moving into air barriers. An air barrier is defined through ABA as a maximum permeance of, this is important to keep in mind, it's going to be, these are 2 different ones, standard or metric, and one is your standard method. It's 0.004 CFM per cubic foot at 1.5 pounds per square foot, or 0.02 liters per square meter at 75 Pascal, and it must be continuous, right? Your air barrier must be continuous. Looking again at zip, we have down here, I'm going to look at, because this comes in at the ASTM 2357, which all of the other ones do align to. We are less than the required amount through the Air Barrier Association of America at 0.2 liters per square meter at 75 Pascal. Here we are with the weather logic, and it just says that the LP weather logic air and water barrier has been evaluated in accordance with, again, ASTM E2357, so it meets that requirement. And force field also comes in. This looks at the other metric, but we're still underneath of the, what was it? 0.004 CFM, and this is coming in at 0.0009 CFM. So again, they all meet the requirement to be used as an air barrier. So moving, again, this is a shorter section to today's webinar, but beyond our standard wood structural sheathings, what about really having an integrated sheathing system? So not only do we have a wood structural panel that has our water resistive barrier applied to it, but it also has insulation adhered to it. If anybody's looking forward to what the 2021 IRC code requirements are for the new climate zone map in Pennsylvania, prescriptively, it's requiring continuous exterior insulation that can be done in a number of different fashions, right? And we will plan to address those many different fashions and how to achieve that, one of which could potentially be one of these products, right? So we have a Huber zip insulated R sheathing, and we have they have 4 different R values that they currently have. Their structural backing is the ZIPS sheathing system. They use a polyiso insulation product, and it's important to know this, that the insulation is interior of the wood structural panel, right? So the outermost layer is going to be the wood structural panel for nailing purposes. There is no facing applied to the polyiso, and the available R values are R3, R6, R9, and R12. LP, which would typically be the weather logic, has a different product called Nova Core. This is a thermal insulated sheathing. This product does not have a water resistive barrier applied to it. However, it does have the insulation applied to it. So if this product was chosen, there would be a need for an additional layer to be installed on the outside as the wood structural panel, or I'm sorry, as the water resistive layer. The structural backing for this is standard OSB sheathing. The insulation is an XPS in this case, and again, the XPS is installed interior of the wood structural panel, so your OSB again is on the exterior side for nailing. There is again no facings applied to this, and there are 3 R values. There's an R3, R5, and an R7.5 for this product. And then the last one that I wanted to kind of just bring up, because it is a little bit outside of the box, is Ox Engineering. It's called Ox IS, and the structural backing for this is a thermoply sheathing. So it's not your typical OSB or plywood. It's a thermoply sheathing, which does provide your structural stability for lateral forces. The insulation is a polyiso core, and this polyiso, the insulation for this product is exterior of the thermoply sheathing. So when installing any sort of cladding over top of it, fasteners will have to be taken into consideration, because you have to now fasten through either a 1/2 inch, 1 inch, or 1.7 inches of polyiso foam insulation to get to your structural studs, because you can't nail that to the thermoply sheathing. So again, different things have to be taken into consideration. It still gives you the ability to have an exterior continuous insulation installed. There is a non-reflective facer, and again, your R values for this product range from 1/2 inch at an R3, 1 inch at an R6, and a 1.7 inch R10. All right, so really quick, now that we're 2 minutes over, is running through this summary, and I just want to say that not all integrated sheathing systems are created equal. There are a lot of similarities, but there are also some fine differences between them. So no matter which one is that's chosen, and please take a look at their installation instructions to make sure that, if a fastener is overdriven, you know how to address that and address that properly for both structural concerns along with the water resistant barrier concerns. Choose the materials that best fit your design assembly. I don't believe that there's um, that everything works for every situation. So make sure that you make sure you choose the product that fits your design assembly. Overdriven fasteners aren't the end of the world, and does not automatically mean that the system will fail. Each individual system does give a means to address overdriven fasteners. So if you're doing an installation, please check that. If you're doing an inspection of that, just ensure that what that depth is it a 1/16 of an inch overdriven? Is it an 1/8 of an inch overdriven? As one, I believe, is Weather Logic that said, well, if you can see the white of the OSB, then you have to readdress the water resistant barrier concerns. So just make sure that you're applying the correct application to the correct product. And again, tying it into the end here, refer to the manufacturer's installation instruction for specific details.